So in this video, I want to revisit our peanut M&M problem where we have the distribution of colors, and I want to show you how we can use technology to do this goodness of fit test. So if I bring in my calculator, the first thing I need to do is enter the observed frequencies and the expected frequencies into two lists. So I have, in this case, already entered the observed frequencies in list 1 and the expected frequencies in list 2 of my calculator. Now you must have the expected counts or the expected frequencies. You cannot just use the probability distribution. It has to be the expected counts or the expected frequencies that we include. So once I have that entered, I'm going to go to Stat and Tests. Now, depending on your calculator, you may not have this command. I'm scrolling down the list of commands under Statistics Tests. In my calculator, it is option D, chi-square GOF test. GOF stands for goodness of fit. If you do not see that command, then you do not have a goodness of fit test on your calculator. If you look at option C, says chi-square test, that is not the same thing. We'll be looking at that chi-square test a little bit later. That's not the same as the chi-square goodness of fit test. So if you don't have this command, you will not be able to use your calculator to do a goodness of fit test. You'll either have to do it by hand or with StatCrunch. So I select the goodness of fit test. What I have to tell the calculator is where are the observed data, and I put the observed data in list 1. Where are the expected values? Those are in list 2. I have to tell the calculator the degrees of freedom. In this case, that will be 5. So once I've done that, I just calculate. So if I round to 3 places, we get 3.569, and that agrees with our by hand calculation. The calculator also tells me the p-value, 0.6130. That also agrees with our by hand calculation that we obtained. So we can use the calculator directly if we have that chi-square GOF test option. Now we can also do a goodness of fit test in StatCrunch. So in StatCrunch, I have already entered my information. We have the colors of the M&Ms, we have the observed frequencies, and then I have the probability distribution that's supposed to be being followed. Now I've entered this, in this case, as the probability distribution, 12% brown, 15% yellow, 12% red, and so on, entering those percentages as a probability distribution, so entering them in decimal form rather than percent form. If you wanted, you could also enter in the expected counts. So we could also have entered in the 48, the 60, the 48, and so on that we had calculated previously. That's up to you, but StatCrunch can handle it either way. Once I have this information in StatCrunch, I can go to Stat and Goodness of Fit. We're doing a chi-square goodness of fit test. So I'm going to select chi-square. All I then have to do is tell StatCrunch where I have the observed data. Well, I put them in a column that I called observed frequencies. And I have to tell StatCrunch where did I put the probability distribution. Well, I put that in the column called distribution. Now, if we have a scenario where all of the frequencies should be the same thing, all of the expected counts should be the same thing, so like we have a uniform distribution, then we could just tell StatCrunch that all the cells should be in equal proportion, so we could choose that option. In this case, that doesn't apply to us, so all I'm going to do is say compute, and when I say compute, StatCrunch returns this window for me. It tells me the value of chi-square, which is 3.569 if I round to 3 places. That agrees with our both by hand result and with our calculator result. It also gives me the p-value, 0.613, which agrees also with our by hand and with our calculator result. StatCrunch also shows me the observed count and the expected count. So I have the observed and the expected. So if we need those expected counts, we have those recorded for us.